Hello viewers, today we are going to see about electromagnet. The core of electromagnets are made of ferromagnetic materials which have high permeability and low retentivity. Core means this is the core. So the core of electromagnets are made of ferromagnetic materials. So the core is made of ferromagnetic materials. We have three types of magnetic materials: diamagnetic material, paramagnetic material, and ferromagnetic material. Okay, so ferromagnetic materials usually will have high permeability. Okay, mu, that is mu is equal to mu naught mu r. So the permeability will be very high and low retentivity. Retentivity means if you see in the BH curve or hysteresis curve, this is H amperes per meters and B Webers per meter square or Tesla. Okay, so when the current is removed, so it goes to saturation. When the current increases, it goes into saturation, and when the current decreases and once the current is removed, still we have magnetic flux density. So the retentivity will be very high in the case of permanent magnets, whereas for electromagnets the retentivity will be very low. It should be very low. Okay, then only we can call it as an electromagnet. That means when current is removed or the switch is open, actually there should not be any magnetic flux density. B should be 0, but B cannot be 0 or it cannot be made into 0. Therefore, at least we should choose a material, ferromagnetic material, such a way that it has low retentivity. That means this value should be very close to 0. So that's the main idea. Generally, soft iron is a suitable material for electromagnets. So we have two types of materials. One is soft iron core and hard iron core. Generally we go for soft iron core for making electromagnets. So generally you have a solenoid. Inside that a soft iron core is there. You have a battery, a rheostat to limit the current. I is the current flowing through the coil. Now we must know what's the current flowing through the coil. Therefore we can connect an ammeter, because the wire should withstand that current. So to limit the current, we connect a series rheostat and on off switch. So you can make an electromagnet or you can break the electromagnet. That means when the switch is on, this will act as an electromagnet. When the switch is off, it works. It loses its magnetic property. Okay. So the battery positive is given here. So the current is varied through the rheostat and the current starts flowing through the coil. So if you view from here, it goes in clockwise. Therefore this is south pole and this is north pole. And as we already told, the retentivity should be very less of the material that we are using as a core. Okay, these are some of the points for making electromagnet. So when the switch is on, this piece of material will act as a magnet. Once the switch is off, it loses its magnetic property. Okay, therefore it loses its magnetic property because there won't be any retentivity. So once the switch is closed, current flows through the coil and acts as a magnet, and if there is no current, it loses its magnetic properties. So we cannot this is the main principle of electromagnet. So the electromagnet works only when there is a current. If not, it does not retain any magnetic property. Okay, so where these are used, if you have seen in olden days, some 20 years back, electric bulbs, they were using this electromagnet. Electric bulbs, loudspeakers, nowadays also you can see loudspeakers. In that there will be a magnet. So in loudspeakers, it is the magnet works on the principle of electromagnetism. telephone diaphragms, and to lift heavy object, a giant electromagnet is used in cranes. So when you close the circuit, the crane will act as by using electromagnetic property. The object is attached and it can lift. Once the switches are open, after placing the object, if you open the switch, then it loses its magnetic property. So these are some of the applications: electric bulbs, loudspeakers, telephone diaphragms, and cranes. We use giant electromagnet. So that's all about electromagnet. Hope you have understood this topic. Thanks for watching. Nandri.